Okay, so I said for my bonus video this week that I would show you how to derive this formula that we have from the general form. So the question is, how do we find an x that solves this equation? Well, the first thing I'm going to do is I'm going to rearrange the equation. So I will move my c over to the other side by taking off c. So I get ax squared plus bx equals minus c. Next I'm going to divide by a, so that I have x squared on its own at the front. So I get x squared plus bx over a equals minus c over a. Now the next stage involves using a trick that's called completing the square. And that's changing this side so that I can write it in the form x plus something squared equals. Because if I can do that, then I get my squared away from my x, and then I can take the square root and it will be much easier to do. So if you remember, if I had, say, x plus a squared, then that would give me x squared plus 2ax, because of the two cross terms, plus a squared. And actually, a probably wasn't a very good choice because we already have an a. Let's call it f instead, a letter that we haven't had yet. So over here, we already kind of have the form x squared plus something x. And this is twice what we would need f to be because of the two cross terms. So, in this case here, f is going to be b over 2a, because it's going to be half of b over a. So b over a divided by 2, because in multiplying this out again, I will get back to this. So, if I know that f is this, if I add f squared to this side, then I can put it into this form and I can take the square root. So if f is that, then f squared is b squared over 4a squared. So I'm going to add that to both sides. And if I didn't have this explanation, it would seem like a really random thing to do. And sometimes in higher level maths, you do need to just take these strange little steps to get you a lot further. So I'm going to add b squared over 4a squared to both sides. So on the left-hand side, I have x squared plus bx over a plus b squared over 4a squared equals minus c over a plus b squared over 4a squared. Then, because I've defined my f to be this already, I know that over this side I can write this as x plus b over 2a all squared. And if you multiply this out again, you'll see that I get back to this. And actually, as a whole, I haven't changed the equation. And over on this side, I want to bring the two expressions over the same denominator, which would be 4a squared is the lowest common denominator of these two fractions. So this first fraction here would become minus 4ac over 4a squared, because I need to multiply this denominator by 4a, plus b squared over 4a squared. So this right-hand side then, I can write, I have x plus b over 2a squared, and on the right-hand side I can write it as minus 4ac plus b squared over 4a squared. And I've written this expression over on the next page so that we can carry on. So, you'll notice that this looks very much like our discriminant, and actually I could rewrite this as b squared minus 4ac over 4a squared. Then I'm going to take the square root of both sides. So on this side then, I have x squared plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, because of course if I take the square root, then it's either the positive one or the negative one, so that's where this plus or minus comes in, all over 2a. And of course, taking the square root of 4a squared, it should really be plus or minus 2a, but we don't need to have this plus or minus here and here, because the whole expression is either going to be positive or negative. So we only need this plus or minus to belong to one term in this division, and it won't change the sign of the answer at the end. So then, what I can do is I can try and isolate x. So, I've just realised that I carried over this incorrectly from the last page. I've got too many squareds going on. As we saw down here, I didn't have any squareds up here, but I was a bit enthusiastic with writing my to the power of 2. So, now we're left with this. And all that's left for me to do is take off this fraction to have x is equal to plus or minus the square root b squared minus 4ac over 2a minus b over 2a, which of course, as these are the same denominator, I can add and subtract these, and it's convention to write this b out the front so that it's not confused and put under the square root, as this is the only thing that belongs in the square root. So we have x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So you see, most of it's just simple algebraic manipulation. I think the trickiest part is probably this completing the square. But if you understand how I got from here to here, then you'll recognize that to go backwards, I need something in this form that I can put back into this, and it makes it easier to solve the equation. I wouldn't expect you to be able to come up with a way like this by yourselves. Even reproducing it is quite a tricky thing, because you do have to have this creativity here and inventiveness. But actually, it's the nice thing to witness about higher level maths, that quite a lot of time people have these ideas of how to solve something, and then they just try it out. It's less formulaic, and it requires this creativity of different ways of solving problems. So it's quite a nice thing to see, and hopefully now you're convinced that our big solution formula here for x1 and x2 works because of what I've just shown you.